Hi and welcome back to another episode of Minute Tidbit Linguistics Edition. Today we're exploring more about the brain and how it handles language. Remember when we spoke about Broca's area, which helps us create language, and Wernicke's area, which helps us understand it. Today, we're going to look at other language-related brain stuff that can sometimes go wrong. First up is speech apraxia, a unique impairment affecting the control of muscles used in speech. It's like wrestling with sounds, even though you know the word you want to say. The insula, a hidden lobe beneath the cerebral cortex, plays a key role in speech articulation. But it gets a bit more complicated. That's because apraxia of speech, and Broca's aphasia, which we previously talked about, can sometimes occur together. This is because these two areas of the brain are quite close to each other, and both conditions are often caused by strokes. Now, let's chat about conduction aphasia. This is when the connection between Broca's and Wernicke's areas, the arcuate fasciculus, is damaged. As a result, people struggle to repeat or mimic words or phrases, even though they should be able to do so easily. To wrap up the aphasia talk, aphasia refers to language disorders that happen when certain brain areas are damaged. Broca's aphasia affects our ability to create language, while Wernicke's aphasia affects understanding. And then there's global aphasia, where someone can't produce or understand language completely, due to severe brain injury. These different aphasias show us how complicated language processing in our brain is. It's not just about distinct areas like Broca's or Wernicke's, but also the connections between them. Moving on to a different aspect of language, reading. There's this thing called the dual route model of reading. It suggests we read in two ways, sounding out words, that's grapheme-phoneme conversion, and automatically knowing words from our mental word bank. This model helps us understand the brain areas involved in reading. A crucial part of our brain for reading is the visual word form area or VWFA. It's activated when we recognize words, no matter where they appear in our field of vision. But for us to read properly, information from both our eyes must come together at the VWFA. Reading problems can be caused by different things. For example, hemianopic alexia is when someone can't see half of their visual field, making it hard to read sentences and longer words. Pure alexia, on the other hand, is when someone can't read even single words, usually because of damage to the VWFA. Lastly, let's talk about dyslexia. Dyslexia is a learning disability that affects reading. People with dyslexia are born with it and have it throughout life. It can make it hard to recognize words, spell, and understand what you're reading. You might wonder what happens in the brain of someone with dyslexia when they read. This leads us back to the VWFA. When a person without dyslexia reads, there's a lot of activity in the language network, including Broca's area, Wernicke's area, and the VWFA. But when someone with dyslexia reads, while they also use these areas, they don't engage the VWFA in the same way. This is true no matter the language. Fixing the VWFA may seem like a solution, but it's not that simple. Since dyslexia is developmental, other brain areas might function differently. Our goal is to identify these areas and understand their differences to develop interventions that target them and improve reading abilities. So, next time you effortlessly speak or understand a sentence, appreciate the amazing brain network making it possible. Thanks for watching this episode of Minute Tidbit. See you next time.